Okay, so hello everybody. So we're here to go and speak to you today, and we're actually going to be doing this talk together. I'm Heidi Helfand, and this is Michael Feathers.
Hi.
Actually, no, the other way around, right? But we'll be talking together about organizational and technological change and how it happens in organizations, and also like a unified view of this type of topic. So I'm going to start out with a little bit of preliminary stuff, and then Heidi's going to go and sort of talk about some other things, and we're going to go back and forth and everything.
Yep,
so.
that's the plan.
Okay.
All right.
All right, see ya. Okay, so this is a weird topic, isn't it? Organizational and technological change impacts above and below the surface. What do we mean by this? Well, it's kind of funny because when you look at what happens in software development, it seems like there's this thing that goes on, right? It's kind of like there's some people that are above the surface and some people that are below the surface. And it's not to say that one side is better than the other or anything like that, but we just have different concerns. So there are people involved in projects who primarily see the team-oriented point of view, or they see the work that needs to be done, or they see the products or the projects and things like this. And then below the surface, we have this. We have code, services, repositories, all the technical artifacts, and quite often the developers are the people who see this point of view of a system, right? Now, the thing about this that I find fascinating is that both of these sides impact the other in rather very subtle ways, right? But quite often we hardly ever have that shared view of the entire system. So for me, basically having done lots and lots of consulting over the decades, right, it's always been fascinating to go and see these ways that things interact with each other and actually impact each other. Many years ago, I visited this organization, and my background really is working with legacy code and just really complicated systems. And they showed me a problem that they had in their code. And this is what it looked like to me. They had this class, this abstraction in code called test base. And it had lots and lots of functions associated with it in this class, right? And when you looked at this, it seemed like there was no cohesion, there's no common purpose to all these functions. And when you're in software, quite often you want that. You want every class to have like a single purpose in a way. But there were many, many things going on in this class. And so I'm looking at this and saying, wow, it looks like many people came into this class and started making modifications, but they weren't even talking to each other. And this was just an inference I was drawing just by looking at the code. So I said this, and they said, oh, well, let me explain this to you. What it is we actually have like about 6 teams that are basically working on this thing, all these products together, and this is part of a testing framework that they're using in common, right? So here are the 6 teams, right? And this testing framework or testing application is kind of like we can visualize it being in the center of this entire thing, right? And the funny thing about it, though, is that essentially no one team was responsible for this testing application at all. Essentially, it was part of this area of code that people wouldn't touch very often, but if they needed something, they would go into this piece of code, make modifications, and then run back to their normal application and start working on things and just using the testing services. So there's a lot of back and forth motion within the organization, people going and stopping their work, going to this testing application, making the additions they need to go and actually do the work they need to do, and then going back. If you looked at this from like a time-oriented point of view, it would be kind of like this. That little chart in the center is kind of like how much activity is happening within this particular piece, the testing application, relative to other things, right? So this is a code problem, right? The code was really messed up, but you can see that essentially the cause was in this thing that we had here, right? We had several different teams working on the same thing with little communication. And at the time when people are working on these things, it's almost like, sometimes they call it part-time code, right? It's code that's not really tended by any one particular group, but people work on it periodically and they make slight modifications. So they lose context when they're doing these kinds of things. So how might one sort of like solve this problem, right? It's interesting to think about. There's a couple of different strategies that we can use. One of them is this, incorporation. What we could say is like this testing framework or application that we have is this thing that we don't really have time to go and really tend by itself. So what if each of these teams took their own copy and sort of maintained it themselves? We kind of cloned the code base, and there's no longer a central testing application, but each one has their own version of it. We could do that sort of thing. It's quite often seen as bad to duplicate code in systems, but sometimes it's the appropriate thing to go and deal with social forces that we have within an organization. So that's one approach. Another one is to actually dedicate a team, a separate team, to go and basically do that work, right? And so this would be the testing team. They would maintain this thing and allow everything to go forward well. The other thing that you can do is you can actually change the testing application itself so that you don't have to go in there and muck with particular pieces over and over again, all these different teams, separating the code that is common across all the teams from the code that's going to be different for each of the teams. You must be presenting like a separate interface to the testing thing, and that would require a bit of intensive work so that you can actually go ahead and sort of like make that happen. So we have several different approaches, and I'm sure there's many more for going and solving this problem. But the thing I want to go and point out is that essentially with this, it's kind of like this is all at the intersection of the social organization of the system and also the technical things that we happen to have. And having that unified view is a very useful thing for us. So quite often we see things this way, that we basically have code and we have the team, and they're very separate things. But I think in reality it's more like this. Essentially all this is kind of mixed in like some kind of a crazy stew, right? So just to mention one little thing here about this, I think it's kind of interesting. Like science fiction time, right? Imagine that you are part of another world, another planet, and you look at the Earth. What do you see, right? Well, people from another planet might not look at the Earth and go and say that humans are the most important thing. They might draw a different conclusion. They might look and see all these EVs and cars that are going all over the place and saying, wow, you have these cars, these things, they're mechanical, and there's a supply chain that goes and produces all their parts. And there's these little fleshy things that basically go ahead and sort of move around and get the cars and tend them, right? The humans. But they would have this view that maybe the cars are primary and the humans are secondary. Is that the correct point of view, or is our point of view the correct point of view, right? In a way, it's kind of arbitrary, right? We can choose what we consider to be primary in a system, right? And in much the same way, with code and team, it's kind of like we can see them as being separate, we can see them as being part of one thing, and all of that can kind of work out well for us. So it's interesting to notice that when we have the code, right, we are able to see social structure portrayed in the code because of the way that it's been worked with. And this is very much like if you think about, how many people know what Conway's Law is? Have you heard about this at all? Yeah, so many of you have. It's the notion that when you have a code system, a software system, its structure is going to end up mirroring the structure of the teams that produce it. And this is not something which is just particular to software. Imagine you go into a room like this. What do you think happened there? Right? Looks like there was a party there, right? Is there any way that this room would have been oriented in this way without there having been a party? Well, maybe if it's a movie set and somebody's going and setting it up to look like a party happened there, this would be what you'd get. But the fact of the matter is that this is, just the way things that kind of happen. When you look at the code, you're going to see the social structure. When you look at the social structure, you're going to see the code as well, right? So I'm going to kind of hand off to Heidi now, who's going to talk about the various different things that you can do at the team level to go and address some of the things we're talking about. So thank you.
Yeah. Mm-hmm. Thanks, Michael. So yeah, we're talking about a couple of different layers here. The team influences the code, and the code influences the team. It's kind of a reciprocal relationship. If we think back to the example that Michael gave at the beginning of this talk, here's a place that I would like to start. So we have all of these teams, and they were together working on that testing app. They came up with some different approaches to how they might solve getting the testing app into better shape. For example, incorporating the testing app and creating copies of it was one potential solution. Another solution is about creating a team to address and get that code into shape. So I'm going to apply some ideas from my book, Dynamic Reteaming, which talks about team change patterns at fast-changing companies. And one of the questions that would come up in this case with that testing framework is, how are we going to create that new team? How are we going to change our teams in order to kind of materialize that new team? So let's go through the 5 patterns of dynamic reteaming We'll go through each one and see, well, which one or which ones can apply to this situation. So the first one is the one-by-one pattern where someone joins your company or someone leaves your company. So if we want to apply this pattern, we would be creating a new team based off of maybe one or more people that we would hire in. That doesn't seem quite right for this scenario because there's a lot of domain knowledge to learn, and we might have a better way of approaching creating this new team. So we'll put that one-by-one pattern aside. Another one of the team change patterns, again, from dynamic reteaming is about the grow and split pattern. And in this case, sometimes you would grow a team larger, like one of those teams around the edges, and then split it. That doesn't seem to really apply here either. Merging pattern is the opposite. So when you're approaching change in your teams, sometimes teams combine to form a larger team. It's quite common these days for larger teams to then reteam around different product opportunities, for example. This one doesn't really seem to apply either. Something's going to apply. Switching pattern is really when someone switches from one team to the next. It could be that someone leaves one of their teams around the edges and works on that testing app, but we know that the testing app needs to serve multiple teams, and maybe that's kind of insufficient. So the isolation pattern is really the one I think that applies most directly. It's when you create a team off to the side. Maybe it's a short-lived team that accomplishes a goal and people go back to the teams, or it could be something that lives on. Sometimes if we have different production incidents, teams will form and disband. To start new product development, sometimes we also create isolated teams. Not a new concept. Some call them strike teams, tiger teams. There's various terms for these types of teams if you look through past writing on the topic of teams. And we're going to take a look at a scaled isolation pattern really for this team, in which we're going to have one or more people form this team, work on that testing framework, and then go back. So we're talking about some of the above the leveled concepts here. Mike, we were talking about how the teams were mirrored in creating that testing framework, and now we're going to take another look and see how we can get the team formed to address this challenge. So whenever creating new teams or changing teams, I always find it's really helpful to take the problem to the teams. And so the problem we're trying to solve is getting that testing framework into shape. And one of the first steps is coming up with a solution. So we have our solution, like we want to create this short-lived team. And so we want to take it to the team to get that input. So the idea for this team could arise from the teams itself, or maybe some different people are talking about how they want to create this team, or it could come from outside the team. Someone else might notice that this is an issue and we need to create the teams. Regardless, getting input from the people that are working in the teams is important. Another tactic is for socializing the change is sharing the before and after. And I think it helps to have visuals like this, where you have a before state and an after state. And if you're going through larger changes in your teams at your companies, it's also almost helpful to have the names of the people who are going to be moving over to the new team, just so it becomes clear. Now, organizations come in various shapes and sizes. Some are more formal, some are less formal. It could be that in a company like yours, people will just go form the team. No big deal. They have the ability to do that. In other cases, people might need to make the case to fund a team to work on a testing framework. In cases like that, I usually go the route of suggesting that people write proposals. You have to influence or persuade people to fund a team. And an acronym that I find helpful that I learned from a people officer I used to work with at Procore Technologies. Her name's Pat Waters. She taught us this framework called the RIDE framework. So at the top of our proposals for a change that we wanted to happen, whether it's the creation of a new team, procurement of a new tool, any kind of change that requires approval and funding, we would put this acronym at the top. So R, who recommends the change? Like someone is bringing up that this change should happen. I is input. Who is giving who has contributed to this proposal and has given feedback and input on the design, like for that new team, for example? Who is the decider? Who is the person that is going to approve this? And E, execute. In order to get this new team to happen, who's going to be in charge of the timeline, maybe project manage the change if it's something larger than an informal team? I also find that when creating the teams, again, we're talking about a team created and informed by the code. It's really important to enable choice. Just telling someone, you and you and you are going to be on this team, sometimes that might work, but in most cases, I find it helpful to try to create a pull system. Who is interested in working on a system like this? Maybe it really motivates someone to help improve and revamp the testing framework. So it's something to consider. So teams evolve and change, it's inevitable. This is, I think, a very good example of how our teams evolve and change. They're not static entities that always stay together. We do our work, we encounter challenges, and then we look at different alternatives, different potential solutions. So for this example, the solution was about creating a team, reteaming related, not all things are. And so I'm going to pass it back over to Michael to continue.
Okay, so in the beginning, I kind of gave this example of things we saw in code that basically gave us an indication of what was happening at the social level within an organization, right? And Heidi basically just gave us a lot of information about how to go and actually execute those changes and what it looks like from the team view when you're going and doing these things. So the thing I keep coming back to is it seems like there really is hardly ever a unifying view for these kinds of things within organizations. You have the people and the technologists, and quite often they're dealing with these intersecting views when they're doing their work. One thing when I started to go and actually try to figure out how to bridge this gap years ago, that I thought would be very beneficial was producing visualizations of the quality of systems, right? And so this is something that some people are using within the industry. We call them design quality views. And what this is you take some architectural view that you have, and it can be rather coarse, right? Just like the major components of a system, and start to colorize the pieces based upon the relative system health of them, right? So in this, basically something that's yellow is rather healthy. Something which is not very healthy, meaning that it's hard to make changes in, tends to be kind of like dark red here, right? The thing about this is that essentially this is something which is accessible both to the technologists and also to the rest of the business in a way, right? And this is very handy when it comes to dealing with technical debt, for instance, right? We've known that technical debt has been a persistent problem across our industry for decades now, right? But with this particular mechanism, in a sense, we can actually make some headway with this, right? Imagine that you have this view of the quality of the system, and then when people are saying, hey, we need this feature, you say, okay, well, you want that feature, but that's touching this piece, and this piece. And you can see that this one's kind of yellow, and here's another one that's kind of yellow, but this other piece is really dark red here. So it's going to impact, how easily we can fit this feature in within the next iteration, for instance, right? And you start to, over time, when you're working this way, you start having people that are not really, technologists going and saying, wow, this area is really red here and it gets in our way all the time. What can you do to fix this? What can you do to actually make the quality better so that our features can become, much more, done much more quickly? And it's kind of funny that you can have that conversation without even talking about technical debt at all, right? And it just comes down to having this transparent view of what's going on in the system, right? So this is another thing that we can do to kind of bridge this gap between, the surface and the below the surface realm. I think it's also kind of useful when you're doing this sort of thing to start to think about the technical part of the system as if it's like a living thing in a way, right? It's kind of like our code systems have health, right? And if they are healthy, then everything goes well. If they're not healthy, we're in trouble, and it basically can jeopardize the long-term, viability of the businesses that we have because we're letting things deteriorate. So looking beyond that, for other ways of going and looking at the system, one thing I've been arriving at an awful lot recently is something I call the active knowledge view. And this is rather abstract, so kind of like, give me a little bit of rope here to go and actually sort of like explain this. Imagine that you're making a change in some part of the system, okay? And if we look at this here, you can imagine the vertical axis being the amount of knowledge that is present within the people about the thing that they happen to be working on in this area of a system, right? So in the very beginning, very few people understand what this thing is that they're working on is really doing. But as they work in that area of the system, their knowledge grows. And they have great familiarity with all the pieces they're working on, right? What happens next? Well, if they're moving on to something else and they don't have to make changes in that area of the system for a while, the knowledge decays a bit, right? It slowly goes away. And the reason it goes away is because sometimes you switch to another team, people switch to different teams, or they leave the company, or they just start to forget things, right? Here's another view. This is like a time series view. We started and we had, very little knowledge, and we gained an awful lot of knowledge by working on something, and it started to decay or deteriorate over time, and then we had more work to do in that area, and then it went and rose up again, right? So you can almost visualize this kind of thing happening within your organization, that you have like this terrain, right, of your entire system. And it's kind of like there's different levels of active knowledge based upon how frequently you've had activity in the system in those areas, right? And so this is a useful way of going in and looking at things, and basically goes and changes some of the perspective we can have in a system, right? For us then, it's no longer about going and saying the code's going to be the highest quality that we can make it. It's no longer about going and saying that the people are going to basically move to different places to go and, get their skills in place to do various things. It's about managing knowledge, managing active knowledge within a system, right? And if we basically have this framing, then it allows us to go make some good decisions about what we want to do when, right? One thing I've seen people do periodically is this thing of like recognizing that there's areas of the system that have not been touched in a long period of time, and going and saying, wow, this is really kind of stale, this area over here. Can we schedule some refactoring or something to do in this area of the system? Because we want to go and start to build up the active knowledge here again, because otherwise we'll lose it, right? You have key people leaving the organization over time and stuff like this. And knowledge is a resource that you have to actually sort of like manage in some sense within an organization. So we've gone through an awful lot of things here to go and discuss the different things that can happen depending upon the view of the system that you have. And just wanted to go and say that I think the interesting thing for us is that we can think about systems purely in terms of the teams, right? Or we can think in terms of the code by itself. But it seems like moving towards the knowledge view kind of helps us a bit, and sort of like reconciling these two views of the system. And I think this is really a great opportunity for us, because quite often it's the missed communication that we have between people that see different views of the system that kind of gets us in trouble. And I think the key thing for us to recognize with all the things that we're doing is that, the system is not just the human system. It's not just the technical system. The entire system itself, combining all those things, is really the unit of care for us within software development. At the end of the day, it's kind of like we have to keep things healthy, both at the human level and also the technical level, in order to go and basically ensure the long-term viability of the systems that we produce. And we miss this quite often. Quite often when you're in organizations that have a strong feature focus or like a strong delivery focus, you start to forget about the health aspects that are going to go and cause you trouble down the line if you don't really tend them. So that's really what we wanted to go and talk about, And so, yeah, thanks very much. Yeah.